All right. Well, welcome everyone, and thank you so much for joining us this evening. My name is Katie Estrada, and I am the Executive Director of Classy, and we are very excited to be able to provide these free webinars to everyone monthly. And tonight we have Dr. Melisa Kaye with us, and she's going to be exploring the vestibular system. Dr. Melisa Kaye has been an occupational therapist for 21 years. She is the founder and director of Firefly Center Therapy Services for Children in the San Francisco Bay Area. She is a university instructor and has taught at Samuel Merritt University in Oakland, California, at the University of San Francisco in the Educational Technology Program, and also at San Jose State University and the Dominican University of California in the Departments of Occupational Therapy. Melisa's teaching and research interests include multimedia learning, sensory processing and integration, kindergarten readiness, autism, and the development of cognitive and metacognitive skills. We are excited to have Dr. Melisa Kaye with us here tonight, and I'm going to hand it over to you, Melisa, to take it away.
Thank you, Katie. Well, welcome everyone. If this is your first time joining one of the webinars, I typically present for about half the time, so about 30 minutes, and then we have the second half of the time for questions. You can feel free to ask questions about the presentation or about anything else sensory integration related, and I will do my best to answer them for you. The conversations, you'll notice this is conversation number 7, so we've had a number of conversations about the theory and practice of sensory integration, and there was some special requests for more information about the vestibular system. So for many of you, at least some of this lecture will be review, and then maybe there'll be some new information as well. I actually have not given a vestibular-only lecture before, so it will be interesting for me as well. And please save your questions till the end, but do jot them down, and I will try to get to them in the second half. All right, so let's get started. This is a picture of Jean Ayers and a client on a scooter board. And she says, gravity is the most constant and universal force in our lives. So when we think about the vestibular system, part of what we think about is our relationship to gravity. And Dr. Ayers talked about the vestibular system in terms of gravity, bilateral integration, postural, academic foundation, a whole bunch of different ways. And we're going to be exploring that as we go. The vestibular system actually has a lot of different functions. So we're going to look a little bit at the functions, and then we'll look at the anatomy, and then we'll come back to kind of a more applied look at using the vestibular system with our clients. So, you know, for many of us that are working in occupational therapy or sensory integration or both, when we introduce the concept of the vestibular system to our clients and their families, we talk about balance. And indeed, the vestibular system is responsible for a lot of our sense of balance. Certainly, when we think about sensory integration, we incorporate the use of the eyes and our proprioceptive system with the vestibular system for balance. But, you know, in a kind of introductory way, we say, yes, the vestibular system is about balancing. And when we talk about balance, we think about both static, in other words, unmoving, and dynamic, meaning in motion balance. The vestibular system also has a lot to do with our orientation in space. So literally, which way is up, which way is down, how is our head oriented to the ground, how is our head oriented to other objects in our environment. It's also about our relationship to gravity. So in part, this idea of orientation in space has to do with gravity, right? So gravity is pulling us down to the ground, and then we rise up out of gravity and are able to move our heads in space to orient. One of the things that's super interesting is thinking about when someone goes into space and gravity changes, either the amount of gravity or not having gravity at all. And a lack of gravity stimulates a lot of vestibular action, right? So we have a situation where literally astronauts would have a hard time knowing which way is up and which way is down without other sorts of cues, because gravity is always telling us where is the Earth and where are we standing. The vestibular system also helps with eye and head position and with tracking. So when you think about it, we can move our heads but keep our eyes focused on a particular point, or we could move our eyes from the left to the right or the top to the bottom and keep our head still. So the vestibular system helps us with both position and tracking and not losing our sense of equilibrium while we're engaged in those activities. You know, Ayer's and current sensory integration theory really talks a lot about the role of the vestibular system in terms of bilateral integration. And why is that? Well, when we look at the anatomy of the vestibular system, we'll see that there are indeed two halves to the system. One resides in either of the ears, and so that makes it a bilateral system. Bilateral integration is based on the integration of two different sides, right? Either left, right, front and back, top and bottom. And so the vestibular system, because it is anatomically a system that exists in two sides of our head, helps with that bilateral integration all over the body, so motoric bilateral integration. The vestibular system also gives us information about movement and position, and typically we think about the proprioceptive system giving us information about movement and position, and it definitely does. But when our vestibular system is activated, which occurs when our head is moving through space, we get information about where we are and the velocity and direction and rate at which we're moving. There are a whole other level of associated functions of the vestibular system, which we'll touch on as we go through the lecture. But for now, let's call that kind of a good introduction to this system. All right, so I have about 5 slides that have diagrams on them, and they're going to gradually take us into different aspects of the vestibular system. I think it's important to look at the anatomy of the system because it gives us a lot of information about how the system functions. I will say that I typically only use images that have been approved for public use, and it was really hard to find images that met that criteria. So I'm going to credit them, and if you would be so kind, please do not share these images with anyone, and they are credited on the slide deck as well. So this one is from bestcare.org. I like this image because it shows us 3 aspects of the ear. The outer ear, which is on the left side of your screen, and there in fact is the earlobe and the auricle and then the auditory canal, so the part of your ear that is going inside your head. And then in yellow, we have the middle ear, which has quite a bit to do with hearing. Your eardrum and your tympanic cavity are there, along with the ossicles, the bones that vibrate for hearing. and your temporal bone, so part of your skull. And then when we get to the kind of the border line between the middle ear and the inner ear, we start seeing the apparatus of the vestibular system, the semicircular ducts, which are often called the semicircular canals as well. We don't see the utricle and saccule in this picture, but we will get there and talk about that. And then if we move in even further into that darker color, we have the auditory tube and the cochlear nerve, which is our nerve for hearing, the cochlea itself, which is that snail-like organ, and the vestibular nerve. So think back to your college days and the vestibulocochlear nerve, right? So the vestibular system and the auditory system actually share a cranial nerve. You can see it in the top right of the drawing that there are two branches to the nerve, and then they join together as they go to the brain. This becomes important when we're treating kids because we sometimes see kids that are having difficulty with part of their hearing system, and it upsets our vestibular system. So, for example, if you have a really bad cold and you get a lot of congestion in your ears and in your sinus cavities, it may in fact upset your sense of balance. It's important to remember with our kids because we have a certain proportion of the population that we treat that has chronic ear infections, and that can affect the function and development of the vestibular system. All right, so now we're zooming in to the vestibular apparatus that is inside the middle/inner ear. So in the top left-hand side, you see the semicircular ducts, and there are three of them. There are and each of them responds to different types of movement. You can also see, if you look in the bottom left, there's the utricle, and the utricle and the saccule react to linear movement. The semicircular canals react to rotary or in a circle movement. So the utricle and the saccule are both kind of oval sac-like structures, and they have slightly different roles within the vestibular system, which is probably not worth going into in this lecture. But if you take away the fact that they're both involved in linear movement, that will serve you very well. Going back to the semicircular canals, there's three. The anterior, which is also called the superior one, the posterior, and the lateral or horizontal. And they've abbreviated that. SSCC is the superior or anterior, the PSCC is the posterior, and the LSCC is the lateral. And they each respond, again, to a different type of rotary or arcing movement. And notice again that we have the cranial nerve 7 and 8 that are very, very close to this whole apparatus. Okay, so now we're zooming in even further, and we're taking a look at what happens within the utricle and saccule and the semicircular canals. So this is a picture of picture A, the utricle or saccule, and you'll see within that sort of oval or egg-shaped little organ, there are hair cells. And then there's something called a gelatinous matrix. I think of it kind of like Jell-O, right? And then there's otoliths. And the otoliths are calcium carbonate crystals, and they rest on top of the gelatinous matrix. And when the hair cells are deformed, in other words, when they move around, which happens with movement, The gelatinous matrix moves and the otoliths move, and that is what gives us our sense of movement, gravity, balance, etc. The same thing happens, let me go back for a second, the same thing happens in the semicircular canals, that there's a very similar setup where there's hair cells. They look a little bit different, but within those tubes, there's hair cells and there's this gelatinous substance, and there are floating otoliths or otoconia, and they move in response to our bodies moving or our heads moving throughout space. The other piece that happens is that there's neurotransmitters within this whole system that relay that information to the vestibular nerve, and the vestibular nerve then takes the information to the brain. So let's now look at the connection between the vestibular apparatus, the vestibular cochlear nerve, and the rest of the brain. Ayers said that the cerebellum's close connection with the vestibular system, receiving information from and sending information back to the vestibular nuclei, requires that every reference to vestibular function imply involvement of that portion of the cerebellum functioning with it. That's from 1972. So what does that mean in plain language? Well, basically it means that the vestibular system is all about movement, right? And the cerebellum is also the part of our brain that rests at the lower posterior section of our brain that is responsible for movement. So when we think about the vestibular system and how it works with balance and with praxis, it's because there's connections that go to a variety of parts of the cerebellum. I hope that makes sense. If I was talking to you in person, I would be looking for confusion on your faces, but since we are all remote, I can't tell. So please do save questions if you have them, and we can come back to this. Take-home message is that the vestibular system and the cerebellum are linked, and that is how the vestibular system helps with motor skill or praxis. Now, in this picture, you see that the vestibulocochlear nerve is also going to the pons, and the medulla oblongata. What that is the brainstem, right? So we know that part of the role of the vestibular system is about self-regulation and arousal, right? So kid is very low arousal. We introduce a swing or other kind of moving apparatus, and it actually alerts or arouses that child, right? By the same token, we can use slow, linear, rhythmic movement to calm a kid down. So why does this work, right? What's the action of this? Well, the brainstem has the reticular formation in it, which is responsible for regulating our wake and sleep cycles, and to a large degree, some of the function of our self-regulatory system. So, vestibulocochlear nerve goes to the cerebellum, not shown in this picture, also goes to the brainstem, shown in this picture, and it means that when we think about vestibular function, we think about motor control and motor skill, and we also think about regulating arousal. And I see someone's microphone is open. So if you guys could just check your little microphone icon in the top left and mute your mic, that would be great. All right. Whoa. So here we have the whole system. So we're going to start left to right. This is another photo or diagram from Pearson, and it simply shows another view of the system. Now check it out. Here we have on the left the ear, right? And then we have the ear canal, and the vestibular system is this teeny tiny little apparatus or set of organs that live inside the middle ear and have a huge impact on our ability to do just about everything. So it's a tiny little, anatomically speaking or size speaking, it's a tiny little system that's very, very powerful. Okay, so moving from the arrow to the vestibular apparatus, we see that the vestibulocochlear nerve comes out, and here we see that it goes to the cerebellum, the vestibular nuclei of the brainstem, that's what the medulla is, also to the reticular formation, which is what I was saying about the wake and sleep cycles and self-regulation. It goes through the thalamus, which is a very central part of the brain, and finally up to the cerebral cortex. So, and then there's a branch coming off the vestibular nuclei that go to the motor neurons controlling eye movements. So when we think about how the vestibular system and the visual system are connected, there it is. There's the anatomy that connects it. When we think about why does the vestibular system help with movement, there it is right at the cerebellum, our movement center. When we think, why does the vestibular system help to either increase or downregulate our arousal state, there it is, the reticular formation, and to some extent the thalamus. And finally, well, why is the vestibular system important for academics, for learning, for language? There it is, the vestibular system through the nerves reaches all the way into the cerebral cortex. So it's a magnificent system, and it's also complicated. I really like this picture because it kind of spells out the whole thing. All right. At this point, I'm going to play a couple very short videos. They're about 2 or 3 minutes. I like them mostly because they give you a little bit of a different view and a little bit more information that that give you a different perspective on the vestibular system. Okay, Katie.
Welcome to 2-Minute Neuroscience, where I simplistically explain neuroscience topics in 2 minutes or less. In this installment, I will discuss the vestibular system. The vestibular system is a sensory system responsible for providing our brain with information about motion, head position, and spatial orientation. It is also involved with motor functions that allow us to keep our balance, stabilize our head and body during movement, and maintain posture. The main components of the vestibular system are found in the inner ear in a system of compartments called the vestibular labyrinth, which is continuous with the cochlea. The vestibular labyrinth contains the semicircular canals, which are 3 tubes that are each situated in a plane in which the head can rotate. Each of the canals can detect one of the following head movements: nodding up and down, shaking side to side, or tilting left and right. The semicircular canals are filled with a fluid called endolymph. When the head is rotated, it causes the movement of endolymph through the canal that corresponds to the plane of movement. The endolymph flows into an expansion of the canal called the ampulla, within which there are hair cells, the sensory receptors of the vestibular system. At the top of each hair cell is a collection of small hairs called stereocilia. The movement of the endolymph causes movement of these stereocilia, which leads to the release of neurotransmitters to send information about the plane of movement to the brain. The vestibular system uses 2 other organs, known as the otolith organs, to detect forward and backward movements and gravitational forces. There are 2 otolith organs in the vestibular labyrinth: the utricle, which detects movements in the horizontal plane, and the saccule, which detects movements in the vertical plane. Within the utricle and saccule, hair cells detect movement when crystals of calcium carbonate called otoconia shift in response to it, leading to movement in the layers below the otoconia and displacement of hair cells.
Okay, so that's vestibular anatomy in 2 minutes. This next video I like because it actually shows kind of a 3D view of some of the anatomy. I think that there may be an error in it, and I will note that afterwards, but the visuals are very compelling. And this one is quite short as well.
The human ear is divided into 3 compartments: the external ear, middle ear, and inner ear. The inner ear contains the spiral-shaped cochlea, where sound waves are transduced into neural signals, and the vestibular complex, which contains the receptors for our sense of equilibrium. The central, egg-shaped cavity is the vestibule, which contains a pair of membranous sacs, the saccule and the utricle. Inside the utricle and saccule are hair cells similar to those in the organ of Corti. The hairs are clustered in the macula, where their processes are embedded in a gelatinous mass and lie under a thin layer of crystals called otoliths. When the head tilts, gravity moves the crystal mass and distorts the stereocilia of the hair cells. This is how the saccule and utricle provide information about position with respect to gravity. Behind the vestibule is the third portion of the bony labyrinth, known as the semicircular canals. The canals project from the posterior region of the vestibule and are responsible for the detection of head motion in 3 spatial planes. The anterior duct senses forward and backward motion. The posterior duct detects moving up and down. The lateral duct senses moving left to right. Each canal contains a membranous semicircular duct where angular momentum is sensed. At the base of each duct is an expansion called the ampulla. Within the ampulla, long stereocilia of hair cells are embedded in the cupula, which sticks out into the endolymph. When your head moves, the endolymph moves the cupula and stimulates the stereocilia.
So the piece that may be a little bit confusing is with the semicircular canals. They respond to turning the head side to side, up and nodding the head up and down, and tilting the head left and right. So just to be clear about that. And I like that video because it kind of shows a 3D view of the system. And guest, yes, the presentation will be saved and will be available via video. So thanks for attending. All right. In terms of organization of the vestibular system, it is a primal, powerful, and sensitive system. Primal in the sense that it develops in utero very early, powerful in the sense that when we have an upset or any sort of difficulty with the vestibular system, which could result in vertigo, for example, it is all-encompassing. Our relationship to gravity and our ability to move our heads through space is powerful, and when that is in any way disturbed, it really disturbs our entire being. And it's a sensitive system, so any kind of small movement or large movement will change the nature and the position of the fluid and the otoliths and the hair cells, and result in a cascade of other effects that ends up being our sense of movement, equilibrium, balance, relationship to gravity, bilateral integration. The system connects to many other parts of the brain, as we've seen. It connects to other sensory systems, the cerebellum, the autonomic nervous system, And we know about this because if the vestibular system is overloaded, we have autonomic nervous system responses like becoming pale, nauseous, changes in our blood pressure and heart rate, etc., sweating. And for those of you that get car sick or motion sick, you know about this. For those of you that are therapists and you have kids that are very, very sensitive and they swang a little bit too much, you know about this. So it's powerful in that sense as well. And then again, just to reiterate, there's the connections to the reticular formation as well. When we think about disorders of the vestibular system, we divide them into two different types: underreactivity and overreactivity. When we think about underreactivity, vestibular bilateral disorder or vestibular language disorder are two commonly seen manifestations of an underreactive vestibular system. So when we think about underreactivity, we think about the child who engages with the post-rotary nystagmus test and has very little or no eye movement after they've been spun. And I'm hoping that you all are familiar with both this terminology and that test, which is in the SIPT, and I believe also will be in the, it will also be in the EASY. So what we want to see is saccades, in other words, eye movements after rotation for a little while. And our reactive kids don't have that. They also are the kids that seek vestibular, but it doesn't seem to actually get in. There is no dizziness. There is no kind of being satiated from vestibular input. And then we have the overreactive kids. So there's two types of overreactivity. One is gravitational insecurity, and the other is intolerance to movement. And we can differentiate these two in that gravitational insecurity has a lot to do with fear, anxiety, or distress when an individual is in an unfamiliar position, or they're moving in a way that they're not familiar or comfortable with, or if someone else is controlling their movement. So there's this big fear component. It could be anything from being on a moving piece of equipment to just stepping off a curb or going into tan bark on a playground. But it's really marked by this fear response. Alternately, the intolerance to movement piece are those kids that become very uncomfortable, motion sick, autonomic nervous system responses with movement, but it's not fear-based, it's that the vestibular system is very sensitive to movement. So overreactivity takes these two different kind of portrayals, and the fear piece is one way to differentiate between the two. Now, this lecture is not about disorders or evaluation or treatment. It's mostly about the theory of how the vestibular system works and the anatomy, physiology, function, but it's important to include a little bit about the various aspects when we see kids therapeutically. So, to that end, this slide is about evaluation, and as most, if not all of you know, it's crucial to conduct a thorough evaluation if we're going to treat a child for a sensory integration difficulty or challenge. There's a number of different kinds of tools that we can use. We can use the SIPT, and as some of you might know, the EASY is currently being normative tested. So at some point in the not too distant future, we will be using the EASY, so a direct test of sensory integration function. We can use clinical observation. We can use questionnaires, which are typically filled out by either educators or caregivers. the two most frequently used, at least in my area, are the sensory profile, which is the SP, and we're on the second version of that, or the sensory processing measure. And finally, occupational interview. And I break the questionnaire versus occupational interview into two different pieces because sometimes I'll get a sensory profile back from a family and I won't really be satisfied with what I've seen there, right? So they've answered the question asked, but I kind of want to know, okay, what does this child really have a hard time with, right? So the questionnaires will reflect a lot of great information about the state of their sensory systems and their sensory integration and what are the behavioral and emotional outcomes of sensory integration. But the occupational interview enables us to dig a little bit deeper and to get some of that qualitative information that can really be important when we engage in a treatment plan. Following an evaluation, we set goals, and I won't linger long on this, but it's important that the goals be functional, based on occupation. In other words, the meaningful activities that a child or an adult, if we're treating an adult for sensory integration issues, meaningful activities that a person engages in their daily life. Now, sensory integration is often called a bottom-up treatment. In other words, we access intervention through the body and through the lower centers of the brain. But the outcomes that we're looking for are actually top-down, in other words, occupation-based. So to that end, we never want to write goals like the child's post-rotary nystagmus will decrease from 30 seconds to 15 seconds. Or conversely, the child's post-rotary nystagmus will increase from 0 to 15 seconds. That's not functional, right? So going back to the top, that's not functional. It's not based on meaningful activity. So it takes a jump and it takes some clinical reasoning to start with, okay, here's the vestibular system. We're going to be working with the vestibular system, but our outcomes, where we want to see the difference, is in terms of postural control, balance for sports, ability to sit at a table, attention to task, academic engagement, things like that. We know that the vestibular system forms a foundation for some of those things, and most of those things. And when we talk about goals, we want to talk about those occupationally based kinds of objectives that we're looking for. Okay, enough about that. Treatment info. So this is not a treatment lecture, and for those of you that are going through the Classy training, you will get a lot of treatment info. But suffice to say that sensory integration therapy and stimulation of the vestibular system is not desensitization therapy. In other words, if a kid is scared of movement or becomes overstimulated either physically or self-regulatory wise, we are not going to force movement on them, and we're not even going to push movement on them. We're going to let them really help determine how much input they want and need. Also, we use stronger systems to help weaker systems. So that if the vestibular system is not functioning well, we may use the visual system to help. We may use input to the proprioceptive system to help. We may even use the auditory system to help. So we pair systems and even group them in 3s or 4s so that the system that is struggling can get some support from the other systems. Again, never forcing vestibular input. Often we pair input with something that the child actually likes and craves. And a common one certainly is proprioceptive input. We also compare a theme or other kind of motivation with vestibular input. For example, if the child's really into pirates, the swing becomes a pirate boat, right? And we have a treasure box that we're trying to dig up from the bottom of the ocean. So we take the vestibular, right? They're on a swing, and we put it into the context of a play activity so that the child is both motivated and engaged and persisting as much as he or she is capable of and wants to do. And finally, with sensory integration therapy in general and with the vestibular system in particular, we want to design the environment so that it's conducive for stimulating the vestibular system, however much or little is appropriate. So to that end, if I'm conducting a session with a kid, I'll have a couple different swings that might be up or might be available. I'll have other kinds of movement activities available. It could be I have a little roller coaster ramp. I use scooter boards. I use a number of different kinds of vestibular apparatus. So we want to design the environment so that it's attractive and it's motivating and it's conducive to engaging in vestibular activity. All right, so we're at the part where you get to ask questions. We have about 20 minutes, and I will put up the last slide. If you'd like to jot down my email, please feel free to reach out and ask questions. I actually am going on holiday tomorrow, but feel free to ask questions anyway. Just know that it might take me a couple days to get back to you. And I'm happy to hear what questions you have about the vestibular system or anything else that I've talked about. You can either type your questions or you can unmute your microphone and simply ask them. You're very welcome, Natalie. Thanks, Alex. So I see a bunch of people are typing. That's great. I encourage you to take advantage of the opportunity. Chances are I'll know something about the answer to your question. If I don't know, I'll find out for you, or potentially someone else who's attending the session will know. Pamela says, I'm from Mexico. Can EASY be used in Mexican children when it is available? The short answer is yes. It is being normed on children internationally. So, yeah, it will be available globally. I don't know about the translation of it into Spanish, but I know that it will be available in a number of languages, I think. And Katie may be able to help us out with that a little bit more. Heidi wants to know, do you have dates for your future scheduled webinars? Well, I'm just finishing up 6 months worth of monthly webinars. This is our last one, and I'll be in touch with Katie and Suzanne and Zoe to look at additional webinars in the fall. I also know that Sue, and another one of the instructors with Classy, is doing some webinars about evaluation, I believe. So you can look for those. And Katie says the next one is July 23rd at 5 p.m. So I'm assuming that will be with Sue Troutman. Christy says, could you give examples of the stronger system helping the weaker system, such as visual, proper, auditory helping vestibular? Sure. And Brianna, yes, I believe that there are links to all of the webinars. So Christy, that's a great question. And think about when you do a session with a kid, and we'll just say that they're on a platform swing, right? What we can do is we can introduce a targeting activity which would engage the visual system, right? So say they're on a platform swing and they have a bunch of bean bags on the swing with them, and we have a couple different buckets, right? So we can help regulate how much the swing is swinging, whether it's swinging in a straight line or, you know, spinning around like crazy. But by giving the child a targeting activity, right, that engages their eyes, helping is maybe not the technical word for it, but what we see clinically is that when a child is engaged and their eyes are focusing on a particular activity, the vestibular system, we pulled it out and said, oh, here's this vestibular system. But in reality, we have all 8 sensory systems working all at the same time. And so when the visual system is working well, we can use that to kind of pair with the vestibular system to enable more input to happen and more self-regulation to happen. I would say proprioceptive, when we pair prop, in other words, some heavy work or play activities. For example, for my kids who have a hard time with any kind of free swinging, they can get on a trampoline, right? So every time they jump, they're getting a nice big boost of proprioception to their ankles, knees, hips. And if they're hanging on to a bar that's on the trampoline, they really can get it to their whole body. And so they're getting some linear input. And I would say this is for the child who has a sensitive vestibular system, either due to gravitational insecurity or intolerance to movement. So we're pairing it to enable access to the vestibular system through another system. And just very shortly, auditory, I'll often play something that has a lot of heavy beat in it and rhythm, and then pair it with rhythmic vestibular. So rhythmic vestibular is inherently down-regulating or calming. And so the child can experience vestibular with that added layer of having some auditory calming. So I hope that helps. Alex asks, what's your thoughts on the astronaut training program? I was trained in the astronaut training program, which for those of you that are not familiar was developed by Mary Kowar, and it involves a board that spins, much like the SIPT post-rotary nystagmus board, and it includes a variety of different activities that mostly involve spinning the child one way and the other way, and then doing that over a period of time. This is my personal opinion and nothing against Mary or any other therapist or technique. What I've started to well, not started, what I have come to over a long period of time is that air sensory integration enables us to get movement, including rotary movement or arcing movement, in a way that has a kind of a deeper level of meaning and functionality. And when we add that meaning and functionality, in other words, sort of the heart of occupational therapy, to our intervention efforts with a child, it's powerful. So I've seen some nice things with astronaut training program, but for me in my practice at this point, I tend to focus on air sensory integration in a larger context. And I would say that I've moved away from, from using the Wilbarger protocol, listening programs, etc. I've had some good results with them, but for me right now, I'm looking at sensory integration in its purest form, and then offering certainly other kinds of therapies to families and adjunct therapies if they want them, because as long as they're not harmful in any way, but not focusing my therapy on them. So that was a long answer to your short question. I hope that was helpful. Other questions? So I see a couple of people typing. While they're asking their questions, it would be really awesome if those of you that are online could just type in where you're living, where you're signing in from. Nice. I always love that part because it just shows that we're so international, and sensory integration is everywhere. So please ask questions if you have them. No need to be shy. If English is not your first language, I don't care. I will decipher what you're writing. And let me say, while you're not typing questions, it took me a really long time to kind of figure out how is it that sensory integration affects praxis. In other words, motor control, motor planning, ideation, all of that stuff, and also affects self-regulation. In other words, either upregulating or downregulating our alertness or our arousal. And the vestibular system is kind of our most powerful and intense system for doing both of those things when you think about it, right? So slow, linear, rhythmic vestibular input can calm a system down and lower one's arousal. We need only think about rocking a baby to see how that works. And Pamela, I see your question. I'll get to it in just a minute. And we can also use the vestibular system to really wake up a client's nervous system. In other words, get them upregulated, increase their arousal level if they start off very low. And we have this entire aspect of the vestibular system that's all about regulating arousal. And then we have this other side that's all about balance and gravity and position in space and head position and eye tracking and posture. And then we layer on top of that our bilateral integration, for example, which is needed for higher level motor activities. We layer on top language, right? So those of you that practice sensory integration, you probably know if you have a kid who's nonverbal, you can put them on a swing and you might not get words out of them, but 9 times out of 10, they actually increase their vocalizations or verbalizations. So how powerful is that? The vestibular system is complex and really worth digging into because it does so much. And Pamela, you know, in preparing for this lecture, I'm actually in my home office. So I would say that sensory integration in the child has a lot of good information, either the 25th anniversary edition or the really super old one, which is, I have both at this point. There is also Schaff and Melot's book about implementing AIR sensory integration, which I like a lot. Good. Let's see, what else do I have on my shelf? Sensory integration and learning disorders, which is 1972 Jean Ayres, a little bit hard to find, but really interesting. And it links up the vestibular system, which is, again, super foundational, with a whole bunch of other layers of function. And then, are you thinking literature for family members to give out, or are you thinking literature to increase your own knowledge? Okay, both. So for family members, Zoe has a little website, and on it are a couple different. There's a couple different links to different sensory systems, and I'm also going to give you my company's website. It's not to promote my company, but I have links there to a number of different books. I don't think I have any podcasts at the moment, but I do have some websites and so on. So I hope that helps. And if I think of any, let's see. I also kind of like sensory integration, a compendium of research. So that helps. So hopefully that gives you some ideas. Okay, Julie asks, how do you explain to families what is going on when a child seeks input through peripheral vision? Current case runs along any edge color change on the wall with eyes moved laterally. So I am making an assumption that this child maybe has autism. Is that true, Julie? Yep. How I typically explain that, and it's not always true, but a lot of times it is, that kids with autism visually become overstimulated, and so looking peripherally rather than centrally helps limit the amount of visual input that is being registered by the brain, and actually enables the child to be more functional in their environment. That's my experience. What do you think of that? Okay, and while you're typing, Brianna says, why do we access PRN in the lateral plane in ASI but not the reflexive eye movements that ideally occur in the vertical plane that are elicited on a spin board in a side-lying position on either side? Brianna, if we're talking about evaluation, I think it's primarily because it's easy to seat a kid on a spinning board and get a head tilt that is standard across kids, and see sort of a gross idea. And in the SIPT, the PRN was actually not a very reliable test, and perhaps we should measure it sideline as well. And hopefully the EASY is going to address that a little bit more. So I agree with you. Sideline, it definitely would be a good measure, and I think we can use it in terms of clinical observations. But think of how much more difficult it is to get a kid to get kind of a standard sideline position, right? So if the kid is sitting up and their legs are crossed in some form, we can kind of get an idea of regulating that a lot more easily than sideline. Interesting question, and hopefully I answered what you were asking. Let me know. Jessica asks, I am just wondering how much information is best to provide to parents, caregivers on the vestibular system in order to inform the session and intervention. Yeah, that's it. Well, the short answer, Jessica, is it depends on the family. Some families want all the information. Other families just want enough to have it make sense to them. So I start with kind of a high level and very pointed discussion. So if their kid is having self-regulation issues, I'm not going to talk about the role of vestibular with praxis, or vice versa. And then I'm going to say, in your middle ear, there's this stuff, and it affects your balance, or it affects, your how alert you are. And I'll give examples that can be relatable. And then I'll kind of gauge, does this family member seem to want more? And then I'll refer them to a series of books, right, or websites, so that they can get a little bit more. And so I take it in a number of stages. I know it took me many years to really understand this, on a deep level, and so I kind of parse out the information that I give families, and I expect that it will take a number of exposures for it to make sense. And then Julie says, I was thinking related to vestibular getting intense input, but you know way more than me. Oh, okay. So peripheral system with intense vestibular input. Got it. And I see that it is a couple minutes after 6. So if you'd like to stick around, I'm going to answer Julie's question. If you need to go, thank you so much for joining us, and we'll just be here for a few more minutes. Okay, so Julie, getting vestibular intense input and looking out the side of your eye. You know how you can, if you're on a moving vehicle and they say, oh, if you look out at the horizon, you're going to get less car sick or less dizzy, or you'll feel much more grounded. I think that this peripheral viewing is actually the opposite of that. So you're having intense vestibular input, and there's various ways that kids can make input more intense. So I've talked a couple times about how to give very down-regulating input. You're welcome, Raquel. But if we want to upregulate a kid and we need the intensity of the vestibular to increase, what we're going to do is we're going to have rapid vestibular, rotary or arcing vestibular, and arrhythmic or unexpected vestibular. So very much like a roller coaster. And if the child really needs a huge boom, they're going to close their eyes, or they're going to look out of the side of their eye, right? So it's a way for the child to increase the vestibular even more. Other things that kids do sometimes that you might have seen is in some way go upside down. So if they're on a swing, they might hang their head over backwards, which makes me want to vomit just looking at it. But for a lot of kids, that's what it takes. And Elizabeth, Sue will not be presenting on the same information. All right, well, we're at 6:05. Thank you, everyone, for sticking around. Again, if you have questions, you can feel free to email me. Thank you, Elizabeth. And if you, if you want to get in touch, just reach out and just know that I will be, I'll be away from my my devices for a few days. And thank you so much for attending tonight. Have a great day, evening,